Hi everyone, this is Jason Yu, and I'm here to present my empirical design. Starting from the institutional details, my paper investigates the dynamic causal links between export performance and macroeconomic factors such as money supply, total reserves, and industrial production total index in the United States from January 1996 to December 2019. The export is quantified by free alongside shift value basis and is analyzed in two cases overall and for commodity categories in specific. The four commodity categories are organic chemicals, motor vehicles, petroleum and petroleum products, medicinal and pharmaceutical products as categorized by SIPC two-digit system. Continuing to my empirical strategy, the empirical strategy used in this study was determined by considering multiple econometric models. First of all, the fixed effect model is able to identify and distinguish effects of each explanatory variables and their interactions on dependent variables. However, this model is limited by time lag effects that could be significant. Further, the dataset used in this study is unsuitable for difference in difference design and instrumental variable models in which it fails to satisfy their model assumptions. Besides these most common econometric models, all three explanatory variables in my dataset exhibit a slow exponential decay in their sample ACF, suggesting that a VAR, vector autoregressive model, is a reasonable choice. Whereas VAR requires stationary series with first difference to original series, and because of this, there's always a possibility of loss of information about the relationship among integrated series. A solution to this issue is differencing the series to make them stationary, but at the cost of ignoring possible long-run relationship between the variables. Since this, a better solution is VECM, vector error correction model, which needs assumption of co-integration between the variables in addition. To ensure the validity of VECM, an augmented Dickey-Fuller test for stationarity and a Johansen test for co-integration are required. Moving forward, my research has experienced a multiple stage of revision. The very earliest empirical design in this paper was limited by omission of industrial growth, which contributes to growth in export performance and is correlated with included independent variable, money supply. To address this, the industrial production total index was later introduced to the model, but meanwhile, it brings aggregation bias in estimation when applying to more temporally and sectorally disaggregated data. Despite these efforts to control for omitted variable bias, the model will still suffer from the exclusion of omitted variables such as inflation, which is measured by CPI, that fails the stationarity test, and others contributing factors that impact the total export and are related with the included independent variable. The inflation is negatively impacting export and positively correlated with money supply. Therefore, the inflation will cause a downward bias. Besides omitted variable bias, the co-integration assumption will presume this relationship between variables are tending towards its long-run path over and beyond the sample period, which is unlikely to have much power if policy change breaks the co-integration relationship. So overall, these issues are left for future research to improve. I'm going to my data source. The data used in this research is collected from the United States Census Bureau, the World Bank, and Fed economic data. And for the relevant analysis sample, M1 and M2 could also represent money supply, but M3 was eventually chosen because M3 is the broadest measure of the economy's money supply. Furthermore, considering that the unpredictable fluctuation of gold price, and that the poor liquidity of gold, which affects the manipulability, um, the total reserve excluding gold was chosen instead. All right, that's everything for my presentation. Thank you guys for listening.